is z equals y squared minus x squared at the point 1, comma negative 2. Then in step 1, I found the z value by plugging in 1, negative 2 into the function to get z equals 3. Then in step 2, I am finding the parametric curve when y equals 2, or negative 2. So t and negative 2 stay the same, and then for my z term, y squared is 4, and it's going to be minus t squared because t is the x term. Then in step 3, I am finding the tangent vector to this curve, so it's going to be the derivative of the space curve that we just found in step 2. So it's going to be 1, 0, negative 2t. And then at that specific point, when you plug it in, you get the vector 1, 0, negative 2. And then for step 4, you're basically doing the same thing, but with x. So you say x equals 1, and then to get the space curve, you do 1, comma 2, and then for your z term, it's going to be x equals t, so t squared minus 1. And then for step 5, the tangent vector, you take the derivative of this, so that's 0, 1, 2t, and then plug in the point. So t equals negative 2, and then you get 0, 1, negative 4. And then for step 6, if you cross these two tangent vectors, you get a normal vector, which can help find the equation of the tangent plane. So when you cross those, you get 2, negative 4, 1, because the partial of fx is negative 2x, and the partial of fy is 2y. Then for step 7, the tangent plane requires a point and a normal, so you use the normal vector you just found, and the point that was given at the beginning, to get z equals 3 minus 2 times x minus 1 minus 4 times y plus 2. And then for step 8, finding the normal using the point and the normal vector, it's just in parametric form. So it's the point plus t times the normal vector, which gives you this in parametric form.
6. Using CalcPlot3D to develop the tangent plane and a normal line. My function is z equals y squared minus x squared at the point 1, comma negative 2.
So I'm going to go ahead and graph the surface and the point.
Now I'm going to graph the parametric curve when y equals negative 2.
Alright, so that's my parametric curve. Okay, so step 3.
Find the tangent vector to this curve at t equals x naught. So we're basically taking the derivative of what we just found.
Oops, I don't want that. So that's going to be 1, 0, negative 2. Oh, I forgot to put it at the initial point. Boom.
That's our tangent vector.
Okay, now for the x equals 1. The x component is going
To be 1. The y component is t. And the z component will be t squared minus 1. So that's the space curve parallel to the zy axis or plane. Now to find the derivative of that,
press vector. And then after taking the derivative of this curve, it's going to be 0, 1, negative 4 at the point 1, negative 2, 3.
so there's our two tangent vectors. The cross product of this will give us a normal vector that we can use to find the equation of the plane.
So after taking the cross product, I got 2, negative 4, 1.
Hopefully that's correct. Of that is 2, which I have here. Then my partial with respect to y is 2y times negative 2 is negative 4. But take the opposite of that, it's going to be 4. And then 1. Negative 1. Let's see if that works. That seems a lot better. Yeah. Okay. And then that's going to change my equation. Using the point in the normal vector, then I found the equation of the plane and put it in parametric equations.
So that's going to make this be a positive 4. That's going to make this be a minus d. Yeah, that makes sense. And then if we take away the function, you can see it.